In one of my earlier videos I had shown that these two filament bulbs for cars can be misused as vacuum tubes. If you make one of the filaments glow white hot and at the same time apply a high voltage between this and the other one, you can observe a current flow. And it is actually strong enough to make an LED glow. The so-called thermoelectric effect makes electrons emerge from the white hot filament, which are then sucked in by the positively charged second filament. You have often asked me if we can somehow build an amplifier by this way. My answer was no, because you would need a grid between the two filaments. But then I came up with an idea, which I will share with you in this video. So stick around. In order to build an amplifier, we need to be able to somehow control the electrons on their way between the two filaments. Amplifier tubes have a grid for this purpose. This holds the electrons more or less back, depending on the voltage applied. Of course, we can hardly open the glass bulb to bring in such a grid, but I found another possible solution. No, not in that way. I will let the anode filament burn out instead. Okay, it's surprisingly robust. Although I have already over 30 volts at it, it is still glowing. Well, I will just have to help it along a bit. What was that good for now? It's hard to see, but there is now a gap at the left side of one of the filaments. With this, the filament which is still intact is the directly heated cathode. The filament lead with the gap is the anode, and the broken filament serves as grid. In theory, an electrostatic field around the broken filament caused by a negative voltage will keep the electrons more or less away from the anode. Let's go ahead and test whether this is also the case in reality. Vacuum tubes are operated with a few hundred volts between the anode and cathode. The voltage from the wall socket is too dangerous, so I built an arrangement of two transformers that form a galvanic insulation. The first one transforms the main voltage to around 15 volt AC, the second one takes it back to about 230 volts. Then I have 4 diodes connected as bridge rectifier and a 15 microfarad capacitor for smoothing. This gives me approximately 330 volt DC. The glow lamp indicates whether the whole thing is currently dangerous. I clamp the black minus wire to the cathode filament and join my multimeter between the plus pole and the anode. Then I fire up the cathode filament with a 12 volt battery and measure the anode current. It is around 12 milliamps, so far nothing new. But now it becomes interesting. I connect the plus clamp of my bench power supply to the intact filament, which is the cathode, and the minus to the broken one, which is the grid. I now slowly increase the voltage and see how the anode current changes. It changes with the grid voltage by more than 1 milliamp. Isn't that cool? This proves that this bulb behaves like a triode. But can we also build an amplifier with it? Let's give it a try. Here I built a small test circuit in which I placed a 10K resistor between anode and plus. Then I measure the voltage between anode and cathode and again apply 30 volt to the grid. With this, the anode voltage is about 159 volt. I take this as a reference and remove the grid voltage now. The anode voltage drops by a bit more than 1 volt, but when the change of the output voltage is smaller than that of the grid voltage, there is no gain at all. In a nutshell, this light bulb actually behaves like a triode. However, the effect of the grid voltage is too small to achieve amplification. So the only place where such a bulb is of any use is in the taillight of a car. Okay, now for the ultimate experiment. I am curious if there is really a vacuum in the bulb or just some gas at low pressure. It's easy to find out. I drop some ink into a bowl of water and stir it. Now if we look closely at the bottom of the bulb, we can see a small stem that seals the bulb where it had either been evacuated or filled with a gas like nitrogen or argon. I hold it under water and try to crush the stem with pliers. The idea behind is that the bulb will be completely filled with water when there is a vacuum. If there is gas in it, the bulb will swallow either no or only a bit of the water. After a while I am successful and the bulb sucks the water in, but only to about half its volume. This proves that there is still some gas left in the bulb. But what really surprises me is that the thermoelectric effect can still be observed. I thought that there must be a complete vacuum for this to happen. Write down below in the comments what you think about this. Just for fun, I light the bulb again to see how long it lasts. Okay, the gas expands under the heat of the filament and squeezes the water out. That's it. Hope you enjoyed. Thanks for watching and see you next time.